Okay, so in this webinar, there's some topic like you will know more about the features of the DTM. DTM is the name of the delta temperature controller, the M series. And then you will know more about the model selection. I think this is very important, especially for the new product. And then it's more about the successful case, Okay, next one. So I think most of the attendee know very well what is the temperature controller, but I still want to introduce again in case someone don't know what is a temperature controller. So basic to say, there's a input sensor here at the beginning to detect the temperature. So normally there's two type of the sensor, which is RTD, for example, the PT100, and also there's a TC, is a thermocouple. For example, it's a K type here. So this is an input to detect the temperature, then send the signal back to the process controller, which is here's I put the Delta DTK series. It's a panel type, so you can see here some feature about the PV and SV, which is present value and a set value. So mostly the controller will process the input, then control by like a PID control, then give an output to the heater, and this is a SSR to relay to control the current, and then control the heater. And this is the normal process of the temperature controller. So I believe in many industries, there's a demand of the temperature controller. So here's a very simple example. Like when you are showering, I think the water, if too hot or too cold, you will be very uncomfortable. So the very stable temperature of the water is very good when you are showering. So this is a thing. For the industry, for the manufacturing, the stable, the temperature is a request. It's a request. I think many industry like food and beverage, like electronics, and also like the plastic and rubbers, there's a demand of the stable temperature. So this is why these things how to do, what is a function. Next is a delta temperature controller family. So here I put all the products here. So you can see we start from the 2003, start from the DTM series. This is a panel mount series, and it's one input and it's one output. What means one sensor input and one output. Normally it's a heater to control the heating. And then right now we have the second generation product so-called the DTK series. So here's some features like fast sampling time. It's 100 milliseconds, and also it's an LCD display, which looks like more brighter, and also shorter body, 60 millimeter. You can see the body, the depth is shorter than before, and also there's a new PID function with the CE and the UL certification. And next one is the DTB type. This one so-called one in and two output. Two output means it can control the heater and the cooler at the same time if the system requires very precisely temperature control. And also we have the second generation product, so-called the DTM Series. So there's a feature like the fuzzy PID, and also it has the analog input, even the 10 volt or 4 to 20 MA. And also it has the feature about the city monitoring. So what is the city monitoring the function? Back to the last peak, we have to give the output to the heaters, right? But sometimes what if the cable, the wiring, sometimes broken or losing from the terminal, we will not know. So that's why the CT monitoring, we can add a CT at the output side. So once the cable, the wiring have something issues, then there's an alarm. We can send the alarm by the controller. Then it's the event control. So we can set up some logic to notify people. So below is we call this all like a panel type. So you can see there's all have a display on the panel. And I believe this is a very common one you see in the market. Most of the users, they are using this type of the temperature controller. And also Delta, we have the modular type. So it's like a multi-loop. So you can see here we have the DTC, it's a modular design, one channel, one modular. And also there's a DTE type, here's a multi-channel design. So at maximum is 8 channels. And now back to the new product, it's a DTM series. So you can see first one, the channel is up to 64 channels. It's very powerful. And the flexible modular extension, I will introduce this later. Simply to say it's more easier than before when you select the model. And also it supports the Ethernet connection, like the Ethernet IP or TCP. This is very good functions, because once you're facing the 64, even more channels, the data exchange will be very, 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 it's a big issue. So Ethernet communication is necessary. And also they have other functions similar as before. So I put another color here. So analog input, CAT monitoring. So basically all the product support the Modbus RS485 communications. Okay, so back to the today's agenda. The first one is a product feature, and next is a product specification. Then is software operation, and we have some successful case sharing. And then last one is promotion. Okay, so for the market demand, we are always listening to the feedback from our customers. So here's some demand like the EIP communication requires, because as we know, the Ethernet IP, the data exchange, the efficiency is better than like Modbus TCP, and also more stable. And also, customer require the easy maintenance, because sometimes when they send the product to the end user side, sometimes you have to do the maintenance. So how to make it easier, how to make it simpler is also required. And also, once they do the software setup, it has to be simple. And also to like a very cost efficiency, and also save the installation space. I think this one is also very important. I think maybe sometimes you can see the control panel inside the factory. There's a big control panel, and at the front there's a many temperature controller, the panel type. So basically the control panel the function is to install the temperature controller, which very waste of the space. And also there's a convenient expansion of the module. I think this is also very important because I think before for the end user to understand how to do the extension of the module is a little bit not so easy because there's some settings and there's some you have to select the input and output. But I think for the DTM there will be no problem for this issue, and also to simplify the wiring, because right now we use the new design, so no more any screw things. We just press and insert the cable. That's all. Okay, here's the picture. There's at the front view of the product. So basically, there's a two part. The first one is the main unit here. You can think in this one more like a CPU. So here's a communication port, and also we have the RS-485 at the bottom side. And at the right side, there's a extension module. I will introduce later for this one. So here's some fixture highlight, like the 64 channel. This 64 channel means the input 64 channel and output 64. Actually, it's more than 64 channels. So mostly the 64 means the input to connect the sensors, and also like Ethernet communication and flexible modular design. And data grouping is because when you're facing to process a lot of data, how to do the exchange is very important. So we have some grouping functions to let you just one time to read all the data from all the channels. I will show this in the software operation later. And for the channel isolation, so for this DTM, we are totally isolated from between each of the channels. And also we have the CT monitoring function. And for the input and output, we support the RTD, TC, and analog input. And also for the output, it's a pulse and relay and current and voltage. So basically can fulfill all the requirements. And here's some suitable application which require the multi-loop temperature controller, like rubber and the plastic, and also like electronics, and also some process control. And so, as I said, for the space, you can see here's a picture. You can image this is a cabinet inside the factory. So as traditional way, people install the panel pipe of the temperature controller at the front side. So you can see actually it's a quite waste of the space, quite a waste of, and no one, I believe not so many people will check the number very details. So this is the traditional way how we do this. So right now we can because this one don't have the display. So normally if customer want to check the real time data for the local side, we suggest to install with HMI and show the data from to the HMI, and also even for the remote side, I can show from the SCADA software. So here's some communication groups like one host and plus the 7 environment modules. For the extension, I will introduce later. And this is the control up to thousands of the temperature control channels. That means what if the customer, they have more than 64 channels, maybe 100, 200. So we have the feature to combine all the data like a big group, then send to the upper system. So this is setting by the software. Okay, so here's some highlight pictures. Like for the single group, I can achieve like 64 point. And also we can see more than 50% of the installation space, because you can see here, I can see already have like 30 channels here. 20 to 30 channels input here. So compare with before, you can see here, we can counting like a 1, 2, 3, multiplying 1, 7. So here's a 21 temperature controller. But right now we just put these things to can replace all of that. So I believe this is a very good, very advantage functions. And this is like a communication. So before the Delta temperature controller, we support the baud rate of the 485 communications like this. I can see for the traditional way, it's already okay because there's not so many data. But when you're facing the more and more channels, the speed must to increase. So that's why we support like 15,000 bps. Okay, and next one is the I could see some group function. So you can see we allow users to define the output address, output 1, output 2, and even the alarm for each of the input sensor. So it's very convenient for wiring, because sometimes if you're wiring already and then you find, oh, I made a mistake. This one should be number 1, not number 3. So for this case, you don't need to do the on-site job again. You just open the software and redefine. Okay, this one, the output, I will link back to the channel input 1. Before it's like a channel 3 linked to channel 1, but because I made a mistake, so don't worry, you just set up at the to change the output to the input. So all the output channels, and we can define the relationship with each of the input. But default setting is followed one by one, but you can change no problem. And next feature is so-called group data grouping. So once we create the power meter in the corresponding group position, you can directly read the parameter group and collect all the meters information at the once. So if you use the temperature similar product as before, so you may facing this kind of issue. The Modbus address is not continuous. So maybe from this 0 to like a 2 triple F, and then next device it start from the like 3000. So I think in the traditional way, you have to write a multiple program to read each of them. But for the DTM, no worry, we can group them as a one group. So you just send one command, and then the system will automatically pull all the data to the upper system by sequence. Then next one is for the installation. You can see right now we changed the design to install to fix the to link with the left side and the right side. So before, if you still remember, for the DTC and DTE series, we used to like move from right to the left to the right. So, but I think this is not so friendly when you install at the control panel. It's fixed on the DIN rail, and I know actually in many situations there's not so much space. So maybe you install some other like a power supply at the left or at the side. So it's very difficult for the workers to remove the modules. But right now we change the design, so you can see we no need to move left move and right move. We vertically to take off the module and then push back again. So I think it's quite convenient and efficiency once you have to do some maintenance. And so here's like a simplified wiring and automatic connection of the host power and other model signals. And this is the model's information I will introduce later. And this is another thing which is very important. It's complete the isolation between the channels. So you can see this is the like input sensors, a thermocouple, and others. So right now we totally isolate from each of the channels. So there will be no in fact the others. So this is very suitable for some situation like there's a high like this kind of the machine. The speed is very fast. So there's some in fact to the like a heavy load, some similar applications. Okay, so let's go to the product specifications. Here's the hardware configuration. I try to make it more easier to understand. So mostly there's we call this host unit, similar like a CPU. So the things include the host and include the measurement extension module and I/O extension module, and output cassette is like a card. So let's back to the picture. This module actually the same thing as a host. So we can see these two slots is input. For each of them support 4 channels. So back to the real things, you can see here this is the input. And for the output, for the standard product, we reserve the slot because the output we don't know what type you need. So we reserve the slot for you to choose. So you just when you select the output card, you just insert to the host, and each of the output card is also 4 channels. So this one is the main host unit. And then next one is the measurement module. So basically, this one pretty similar like the host unit. So it also has the input and reserve the output slot for you to select the cassette. So this one is a measurement extension module, and the maximum is 7. So you can count basically simple counting the 7 module plus the host unit. So totally it's 8 unit, and each of them support the input 8 channels. So very simple mathematics. It supports the 64 input channels. And also for the yellow part, we call this one the I/O extension module. This one is pretty slim, but this one only has the output. Because sometimes the application requires a multi-output. So that's why we also support this one. Maximum is 7. Okay. And this is looking from the bottom side. So you can see the host, the measurement, and all the scene sequence. And we support the RS-485 here. And also here's the DC power supply. And this is to install the cassette, reserve the slot to insert the cassette. You can insert from this from side to here. Okay. Okay, then we go to the host unit introduction. So basically we have two types, RS-485 type, and you can see there's the R, which stands for the RS. And also there's Ethernet type, which you can see the model, there's a E. So basically you can see the dimension is quite slim, and there's some indicator and input terminal. This is no need the screw working. Just press the yellow part and then insert the cables. And also we support the mini USB, which is a link with our laptop to do the download and upload things. And this is the communication station ID. It's more like a Modbus ID link with the outside, and then it's a reserve the output cassette. So this is and for the Ethernet type, the only difference is we change the mini USB to the Ethernet. So this one we can do like do the programming and set up the software operation, and also exchange the data. So this is all the host unit, not so many modules. We A08 means we have support 8 channel input, and 04 means we support 4 input channels. The next one is a measurement extension module. For this one, you could see it's quite similar like the host unit. So basically, you could see most of them is the same, even the dimensions. And for this one, also we have like there are 8 channels input and 4 channel input. And this one is a slim one, but normally we select this 08 and 04, these two models. Then next one is the output cassette. So you can see these small things has 4 channel output, and this is a type. So like the pulse output 40. Normally this one linked with the SSR. Because of the heater requires a very huge power consumption, so that's why we need to use the SSR. The next one is a relay contact, and also we support the analog output, which is not so common usage, but we still support the 4 to 20 ampere, MA, and 0 to 10 volt voltage output. And this is the dimensions. And last one is the L module. As I said before, this one only support the output, but you can see it's quite slim design. So there's also like a pulse output, really similar. I like a cassette, like the output card. And we have one more special module. This one is a CT input. This one not output. It's a CT input, only monitoring the wiring connect to the heaters. And we have 2 spec right now, which support the 30 ampere and the 100 amperes. And also we also can support the CT unit. Then back to the detail module. Here I highlight the common you use the module. So you can see for the measurement, for the host, there's 4 module on cell, and for for this one, I recommend it has 8 channels and support the Ethernet. And also, of course, if you think Ethernet is not necessary, and you also can select the RS485 type, no problem. Next one is the measurement extension module. All the on-cell model here, and also this one is a common used model, which is 8 channels input here. And next is the output cassette. You can see here, this is the 1, 2, 3, 4. This is all the output cassette. This is not include from the host and the measurement. This one you have to purchase separately. So I also highlight the 2 type, which is a pulse out voltage and the relay output. This is a very common use. And last one is the I/O module. You can see this one. We have the almost the output and exclude the CT input. So this is all the model selections. And here I list some details. You can have a reference. I will upload this present material to the website. You can check the detail later. Next is software operation. So let's see. First, the software is totally different from before. And this is a connection between the software and DTM. So you can see here's a laptop. We have 3 ways to do the programming, the download and upload configuration. So it supports Ethernet and also the micro USB to link with the device, and also we support RS485. If you have the converter, if you have the USB to the RS485 converter, you can also use that one. So in this case, I will make an example how we do the software operation by these 1, 2, 3, 4 modules. So you can see we separate by the colors. The gray one is the host unit, and also we set up the station ID as a 3. And next one is the measurement. We point out by the green color, and also there's a 2 yellow one. It's a I/O module. So there also has the internal station number 0, 1, 2, 3. This one only recognized by the software internally. Okay, let's see. So how we gonna start the operation? First one, open the software DTM, which you can download from the website, and create a new project. And then create a new project. Then it's next. Then you have to select the online monitoring. Then system will automatically shows the connections. And so by now you have to select which one you are using now. So for example, we use the RS485. So we have to set up the basic parameters. Then we go to the next to start the scan. Start to scan the DTM. So the system will scanning. Once the scan successfully, you will see there's some more information pop up. So you can see the current DTM configuration on the left side of the screen, as shown in the figure below here. So there's a group of the DTM with a station number 3. 3 here shows, and there's a master. You could see the ID is 0, and the extension module, the number is number 1. Then you can continue to click the button unit settings to see the complete DTM configuration. Then there's shown the figure as below. You can see there's a part. First one is a main unit. You can see there's an internal station, which is a 0. It's a host unit. Then this one, the internal station is the number 1, which is a measurement unit. And there's 2 and 3, which is I/O extension module. So we continue to the next one. Click the button online monitoring to monitor the common parameters of each of the group as shown here. So we select the host unit, then it shows the input and the PV and also the SV, the values all here. And also you can check the status and the alarms. So this is all the details. Then if you want to do some settings, you could go to the parameter settings. This one also, for example, the host unit. So you can see there's many things you can do, like input type, whether it's a thermocouple, and upper limit of the SV and the lower limit. This is for the alarm, and also some offset and gain, and also some filtering and range, and the event. What if the input value, the logic, the conditions, and also you can also decide to disable the channel or not. And this one to show how to do the parameter grouping. So you could click on the group of the button parameter settings, this one, and select the I/O position button here to configure the output of the channel. Shows here. So here's an example. You can see this is the output. Number 1, output number 1. So okay. So this means the output number 1 will link to the input channel number 1, output 1. 0 is the internal address. So this one linked to the host unit, the first input channel. The output channel will link to this one. And next example is the output number 2. You can see the host unit, the output number 2 will link to this one. And also the alarm is same thing. So this is how we do the grouping. So basically all the channels you can modify by yourself. Okay, this is all the software operationing. And next one is the successful case sharing. First one is the paper cup machine. Paper cup is very common. When you go outside, you want drink waters, you probably could use the paper cup. So this machine to stick the paper. So the feature is because we improve the PID control functions, so the ISV, you could see the surprise, the overshot is very reduced a lot. This is the after improvement curve, so it's very efficiency and very stable from the PV to the SV. So next one shows the vacuum forming machine. This one is a little special. Basically, you can see this is a heating area. This is the heating area. There's a 9 area need to do the heating. But this customer, they want to reduce the input sensor because it's very difficult to maintain if you install 9 sensors. You can see the machine is totally already blocked. So the customer, they want to reduce the input sensor. So for this case, we only have 1 sensor in the center, and there's a 9 output. So the feature is we can modify the output ratio for each of the channel. For example, this one, we give them the 100% output. And for this one, only 90% output. And for this one, even 50, because this one, for the users, they can, according to their experience, to set up by themselves. So the system only have one thermocouple and then can control all the area. So this is a very convenient function for the software, the user defined the output. It's very convenient for these users. And next one is the water cooling plastic extruding machine. This one is a little special because this one uses two output. One is a heater, one is a cooling, because the customer want to control the temperature very, very precisely. To see the SV, this area, the temperature must control inside this area. So that's why we have two output, which is actually there's a two PID inside. So we call this one dual PID independent operationing.